thermal models. So wetlands water intensive seawater basically dry solvent injection and ammonia based.
Welcome back. Now we move on to our session on establishing water balance and flow management. Given the accumulating water-related pressures on power plants, they need to have a clear understanding on how they manage water and wastewater internally. Developing a plant-wide master plan for water management is the first step. A comprehensive site-wide strategy for maximizing water use efficiency, minimizing wastewater discharge, and reuse or recycling to the maximum extent possible is the need of the hour. We'll be now exploring how to establish water balance and flow management. So I would request Mr. Khatri to please welcome our speakers on stage. I will just give an introduction. We will have Mr. P.K. Bandhu, Head of Environment Tata Power, who will be making a presentation, and Dr. Bhola Prasad Kushwaha, Senior Manager Environment of MB Power, who will be making the presentation.
I think there is some problem with the access to the mics of both the participants. Let me just try to take a break and connect them back and come back in few moments, please.
When it passes to the
Sure.
ESP, because of the heavier reactor, the number of equipment everything is very less. So we have seen all the technologies. Now we see how to select the technology.
Anisha, the same problem that there is a back-end access not given by him. Let the IT team is started talking to them. Give us few more minutes so that we can resolve the problem.
Okay, so we'll take a break and be back soon. Welcome back. We are now going to have another presentation, and in this session, we will be talking about implementing technologies for efficient water utilization and consumption. Mr.
Anisha
Vijay
ji,
Kumar,
I'm not able to hear you.
Mr. Vijay Kumar, the Director of SWAN Environment is with us. Mr. Kumar, we can hear you clearly. Could you please turn on your video?
No, I'm unable to hear what Anisha ji is telling, and my video also not activating. Video, it says, if I say, it is say, please ensure that AirMate has access to your camera from your browser permission.
Yes, sir. So I think there must be a pop-up blocker which you'll have to unlock. Yeah. Could you do that? Maybe disable the blocker and then we can see your video.
To see that, but video, I'm.
So while we figured out the technical details for Mr. Vijay Kumar to join us, let's talk about the topic. Water intensity in power generation is a function of the fuel type, the technology used, and water conservational practices followed during energy generation. Now, climate, technology, processes, these are all factors that need to be evaluated when you're considering trade-offs. By building cooling towers...
Can anybody able to hear me?
Yes, Mr. Kumar, we can hear you.
I am not able to hear here. I am not able to understand. Even the video button is not activate.
Mhm. I don't know for uh, we are unable to get the video of Mr. Vijay Kumar going. Mr. Kumar, were you able
Okay.
to?
So how to share my screen? Arrow button. Yeah. Share the screen, right?
Yes.
Okay. Yes. Okay. Okay. PPT mode is there, but yeah, you are able to see,
Yes, we're able to see.
but I cannot see anything. So can I go ahead?
Yes, sir. If you can see your presentation, please go ahead.
Yes. Yeah. Okay. Thank you. So everybody can hear my voice, right?
Yes, we can.
Okay. Thank you. Yeah, sorry for some glitches. Let me introduce myself, Vijay Kumar from Swan Environmental. I'll go quickly my company presentation, then to the subject. Swan was established in 1988, almost 30 years old company. The name derived from 5 elements like soil, water, air, noise, for 5 or 4 elements. So we are dealing all analytical instrument monitoring this. So it is contributing to the environment. We are market leaders, and we have now group of companies uh, since with 30 years experience and more than 36 global partners. We have all over India network, and we have more than 200 employees. This is our head office in Hyderabad. These are all our global partners. Uh, Product glance, we supply complete continuous ambient air monitoring stations, fixed or mobile, with as per CPCB state PCB guidelines. Also, continuous effluent monitoring system, wastewater monitoring. We have supplied to all NTPC projects. Then stack emission monitoring, source monitoring, emission gas analyzers we supply, and portable environmental. And also we have water level loggers, which is again becoming very important for groundwater level monitoring, and many other environmental products like odor, sound level meters, portable samplers and all that. Complete industrializing workplace hazards monitoring in workers exposure monitoring in industry like noise, physical exposure, chemical exposures, and safety items like gas detection, leak detection equipment, and complete workplace hazards. We have a complete solution. We are pioneers in that. And water quality monitoring, we have complete laboratory instruments as well as online instruments for water testing. Especially today, I'm talking about TOC and water level. Also, as I said, rainwater harvesting. People need to also monitor their groundwater level and report to the Ministry of Environment. Now it's one of the requirements. And also rapid microbial systems for Legionella bacteria in cooling water. We have one application. So we have government, we supply to government sector, institutionals and industries. So let me go to my today's presentation. TOC monitoring in industry, why it is so important. So TOC and what is TOC, why it is required, TOC in source water, drinking water, processed water, wastewater, TOC technologies and our solutions, and some references. Organic pollution, when we talk water contains naturally carbon, hydrogen, oxygen. Organics to certain extent is required for living microorganisms, but if it is very high, it will become excess, then it will become a pollutant. Then we know that organics are there everywhere. Excess organic create the pollutions. A variety of emerging organic contaminants were discovered in water source in the past few decades due to industrialization, domestic even discharges, sewage and hazardous waste dumps, and so many activities, agriculture activities is causing this. So organic contamination is one of the category of pollution that need to be monitored in wastewater due to significance, and multitude of organic compounds are there. So the concept of some parameter, one parameter we define. So based on either conventional methods like BOD, COD, and TOC. These are normal parameters we normally come across. What is TOC? Measurement of total organic carbon present in different matrix. So index of amount of organic substance in the water. Typical, the index shows the water quality, very low, very good, very high, very poor. There was one magazine I've seen in Korea. They give water quality index based on TOC. Almost 7 category water I see between 2 ppm to 8 ppm. So this is what when we talk organics is a big pie chart, in the complete scenario, since organics many, natural organic matter, dyes, organic chemicals, making solvents, cosmetics, pharmaceuticals, microorganisms, sludges, oil and gas, and petrochemicals. Compared to inorganic, organic is a major part. Even we are also organic. So the two conventional but indirect, they are called oxygen demand, what we are measuring based on organic load. So COD and BOD. BOD is biological oxygen demand, the amount of dissolved oxygen needed for the bacteria to eat the organic waste. So this is normally 5 days to 3 days test. You require a DO measurement, then put in incubator at 20 degrees centigrade, and a demand of oxygen depleted for 5 days. Again, it will be calculated by measuring the final DO. Similarly, there is another direct measuring technique that is called manometric technique, with where we keep the wastewater in a magnetic stirrer, continuously stirs. So waste is taken by bacteria, and there is oxygen consumption. There will be a pressure drop in the bottle. There will be that pressure drop is directly proportional to BOD. Then again, you have to keep in an incubator. But this is a quite tedious and time consuming. Similarly, COD, 3 hours minimum, and you require toxic chemicals to do the analysis. Whether one is open reflux oxidation measuring, and there is closed reflux oxidation measuring technique. So closed is same. Open, what you do, also available in a simple form where without any big infrastructure, chemist you can do. Basically add the potassium dichromate, sulfuric acid, and digest for 1 and 2 hours at 150 degrees centigrade, and measure directly COD. So this is the two methods for COD, BOD. But all these methods, there's a huge error will be possible. This is due to preparation of samples, sample collection, transportation, laboratory test. Everything contributes some error. That will be almost 20% plus or minus errors are happening in BOD, plus or minus 10 in case of COD. Other side, TOC is a fast and accurate and direct measurement of organic. We are not doing any indirect oxygen demand. Wide measuring range, 4 ppb to 30,000 ppm. So automatic analysis, no person's interventions, fast results, plus or minus 2% accuracy. All are approved method-based technologies are available. Okay, so TOC is the best alternative. Why? BOD is a tedious, taking 3 to 5 days. COD is tedious, take 3 hours. Again, use pollutant, harmful chemicals to do the analysis. So in spite of you have a good facility, also again getting a good results of BOD is a question mark. On the other hand, TOC is easy, fast, and reliable. So that's why global people tendency to move to TOC away from COD, BOD. By measuring TOC, you can also understand COD, BOD. Some correlation can be established. So now measuring instruments available, lab as well as online. So it is an indispensable tool for both regulatory compliance and process control. So let me go to how it is going to be important, especially in power plants. So let us start from the source water. So what type of source water you are using, river, lake, ground, rain, or sea waters, or process water? What type of treatment you are going through? Of course, all power plant required RO, MF, desalinated, or DM, demineralized water. So this is very common. So boiler, feed water, cooling water, recycled water, wastewater. Again, I'll discuss about this. When we talk to source water, TOC has a significant role in the source water quality to understand what good quality it comes, number one. Number two, it changes in the seasonal wise. Sometime rainy season it will be different, summer season it will be different, and also it depends on what type of water you are receiving, what type of upstream activities are occurring. So how do you know? By measuring TOC periodically, you will know your water quality is coming good or not. That's why rivers very good, quickly it measures, so you don't require to wait for a long time. That is the advantage here. Seawater also, a lot of seawater protection TOC been asked to measure. Lakes also, groundwater also, since a lot of it is an available diagnostic tool to see any groundwater is getting contaminated, any leachings are happening, landfill leaches are happening. Rainwater again, people are using now rainwater for harvesting, and it is also a huge amount of water which you can reuse it. But rainwater has a tendency to bring non-point source pollutants through rain, so you need to know the quality to take a decision whether it required a treatment or it can be used directly. So there are many countries who gave limits for source water around 4 to 5 ppm, but in India this is missing. And when it is to come to the drinking water, even I see a lot of NTPC plants, they have their own drinking planter for their township supply. So in the drinking water also, the TOC limits are being defined between 1 ppm to 3 ppm. This is for disinfection byproduct rule. To control trihalomethane, one of the disinfectant you can anticipate by chlorination is trihalomethane, which is a carcinogenic. So to ensure that, you need to make sure TOC is removed before disinfection. TOC should be less than 2 ppm. Even trihalomethane forms, it will be within the acceptable limit. Similarly, ozone dosening people are doing. The amount of organic will define the amount of ozone to be dosed. That is very important to effective disinfection. So this is normally, if you see any drinking water treatment, coagulation, sedimentation, filtration, then disinfection and distribution. So in all these areas, TOCs are getting removed. So that's where you need to understand. If you see a water flow in general industry or in power plant, for example, rivers and lake, whatever water you are getting, it goes to your clarifiers, then it will go to the ultrafiltration, then RO filtration, then demineralization, then storage, tanks, and then goes to the boilers. This is one stream. Another stream is you have from clarifiers, it will go to the cooling water inlet bay, and then it is used for cooling towers. So when we talk about water treatment, the most TOC that have been suspended, soluble, insoluble form is to be removed by ion exchange towers, charcoal towers, RO filters. UF filters are designed on flow rate and organic concentration. So TOC monitoring is efficiency for checking, planning, backwash, regeneration, frequency maintenance, shedding. So if you don't measure, definitely don't know how much is removed. There is a possibility a lot of things cannot be removed. So, but by monitoring, you will come to know about it. So it's very important that you need to do. Of course, many people water chemistry in a power plant, they know all these things, but still I want to say a little bit things here that membrane filtration, ultrafiltration, ion exchange towers, everything required some regeneration or backwash for make sure that accumulation of organics are not happening for a long time, which deteriorates the product quality. So when to stop the backwash, how much you require backwash is TOC is a good indicator for that, since you are using a good water for that. So all this regeneration water backwash again to go through some neutralization pit and can be reused again. So this is how you take a decision by monitoring TOC. See, actually TOC, if you see power plant earlier, this was not a parameter. You normally come across silica or sodium or cationic conductivity, dissolved oxygen. This type of terminology or conductivity, these are terminologies normally you come across. But TOC found to be hidden problem, NTPC has done or research. Now all their chemistry department, they are buying a TOC analyzer, periodically check the water quality at different areas. Typically, if you see a power plant, these are the two circuits. One is boiler feed water to the boilers, then turbine, condensator, then goes back like this. And here it is open circuit. So the cooling tower water is pumped inside the condenser tubes to the cooling tower to reduce the temperature. So the temperature pickup here is coming down back here, cool down here. So this is a wonder cycle. So in these cycles, boiler water, TOC is a very, very dangerous. We are talking the limits was given by EPRI, ESCOM, that 100 ppb to 250 ppb. People may think that my DM water has a good quality, it doesn't have a TOC, but it can come up again. Since due to seasonal influence on the source water, untreated natural organic matter, untreated trihalomethanes, resins breakdown, polisher fouling, treatment chemicals. Sometimes you use a lot of treatment chemicals. These treatment chemicals may be inorganic chemicals, but if there is a organic contamination, it can contribute. Lubricant oil spillage, a lot of rotation machinery is possible if oil leakages, or heat exchanger pinholes can cause some leaks again. So all these possible areas TOC can come back. Since we are talking very low, low amount of TOC here, if we don't care what happened, high pressure temperature, it forms into organic acids and we corrodes the entire system. And accumulated organics sometimes can into decompose into acetate formate CO2, which may also your cationic conductivity show as a cationic conductivity. People will mistake this with chloride on sulfate and they do treatment for that rather than the actual problem is TOC. So anything inside boiler which have a high TOC content, all this corrosion can occur for all these parts. So boiler pipes, boiler turbine blades, condenser pipes on the top side, and HPLP heaters. So by monitoring TOC in feed water, elevated organic levels, it will very important to know that why it is coming. So it is due to leaks in the heat exchanger or improved system efficiency, or you by monitoring you can reduce the chance of downtime due to corrosion, avoid boiler foulings, boiler protection, water use optimization, energy optimization, chemical additive cost reduction, makeup water cost reduction, wastewater plant cost reduction. Everything is boils down to that. Then next subject is cooling tower water. Cooling tower water, it is this is the condenser, this is the inlet bay, then cooling water is pumped into the condenser inside tubes, then goes here, tower, then it will sprinkle down back the bay, so there will be pressure, the temperature cool down phenomena occurs. So this is the normal circuit. So here the most interesting is it's a good atmosphere for microbial fouling. Microbial fouling will happen if you have high TOC. So the more the biofilm forms, there's a severe effect like microbial influenced corrosions, water flow reductions, reduced heat transfer efficiency, increased delta pressure across heat exchangers and reduced flow, health risks like Legionella bacteria, and damage to the wood and tower structure. And I can say the biofilm more insulating than calcium scaling 4 times. So you lose your condenser heat exchanger efficiency drastically. If you see eutrophication in the reservoirs or thick algae foaming, these are all indication you have a high TOC. So if there is a TOC high, this type of things can occur. All these green algae, wood tower structures, everything you will find the biofilms. So there's one interesting article I have seen. If you know inlet bay TOC, makeup water TOC, 10 ppm for example, 7 tower cycle operation, this goes to almost 70 ppm, where you need to discard this water, bleed down or blow down. And this water has to go for treatment for that. Otherwise, what happens if you use like that, within no time you have a high bacteria growing. And so people also use biocidal chemicals. You can avoid that. If you know your TOC, you can decide how many tower cycle you can pass through it. Instead of thumb rule, you discard it. This is how you save the money. Next, last subject is wastewater. Globally, already TOC has been introduced long back as an alternative for COD, BOD. See, our CPCB now asks COD, BOD online monitoring, but in fact, they should have asked TOC since it will be easy to validate and easy to know. And there were so many countries that gave limits. Anywhere between 25 to 75 ppm are the limits was being given, or 1/3 of COD limit you can take as a TOC as a limit. CPCB also, in CPCB wastewater, they have mentioned TOC analysis method, and also they say TOC is more convenient, direct expression of organic content there than BOD and COD. So further, also TOC has been accepted for reporting COD, BOD. This method also accepted anyway. Many CETP melts, I see clearly TOC monitoring we asked to have for process optimization. So if you see typically water collected at all these CTPs, equipment floor, so equipment floor drain, HFO, LDO, storage, all containing wastewater treatment, equipment, unit wise. All these are collected here. So this is how reuse system being used. So TOC at different points monitoring, you can do that. So ZLD concepts are emerging. So TOC is an immense useful tool for doing that. And TOC is the most suitable parameter to measure organic load. By online monitoring, TOC tremendous opportunity uh, without hazardous chemicals. Organic load is the most important monitor for STP, ETP plant performance. TOC empowers operator knowledge to make a critical process decisions when to maintain something. Otherwise, you are spoiling a lot of equipment. So it is a asset protection and regulatory monitoring. Both you can do. Process control you can do. Asset protection you can do. Direct influent monitoring carbon at municipal wastewater plants can help enhance the biological treatment. Gaining approval tool to improving the durability of water treatment asset. Optimal food to micrograms ratio. UFRO membrane optimization. So many helps are there. So I don't know how much time I have, but of course I have what is TOC, why I already explained why it is so important in power plants. I explained by measuring TOC, the terminologies is TOC, TC, IC, NPOC, NPOC. I don't know, some sound is coming. I don't know, it is. Two methods are available measuring TOC, difference method, additional method. Difference is TC minus IC. Like this is the TOC typical analyzer. Sample is injected at 680 catalytic conversion, convert CO2 is detected in NDIR. Then we have another is IC. By injecting water into IC reaction vessel, acid will convert IC into CO2 detected here. TC minus IC, or NPOC is remove IC, measured balance as a NPOC. That is also another method available. So we use the syringe itself as a reaction vessel. Sample is sucked, diluted, and then acidified here. Removed IC, then measured TOC. This is another method. So
Mr. Kumar, I'm sorry to interrupt you.
Best technologies, catalytic conversion technique is the best technology. There are online instrument, lab TOC instruments available. Lab TOC with high sensitivity, normal sensitivity, with PC, without
Mr.
PC
Kumar?
option. So we have 4 ppb detection and TC minus IC, adaptive to several applications for hello.
We lost your PPT.
Yeah, Miguel?
We lost your PPT.
Yes, some sound is coming. I don't know. I don't know what is that. So how to get back?
Can you stop sharing and reshare it again?
Okay. When did you last exactly?
I'm not sure because I was not in front of the screen.
Okay.
There is another program happening, so I was in this both.
Okay. You're able to see my presentation. Looks at my. Yeah. Hello. Yeah.
Yeah, Vijay.
Yeah. I'm just stop my. Just a minute, please.
Yeah, you can reshare again.
You are able to see now?
Yeah, you have to minimize this and open your presentation.
Can you see my presentation now?
Right.
Okay.
Please put it on full screen.
Yeah, exactly where it stopped, I don't know. So I am trying to explain how the TOC analysis is happening. Okay.
Sure, we can see a slide.
Okay. I don't know when it is stopped, but let me do it from here. Okay.
Sure.
So TOC is a revolutionary parameter, most suitable parameter to measure organic load. By online monitoring, tremendous opportunity to optimize plant performance. shorter measuring cycles. So organic load is the most important for STP, ETP performance, and it empowers the operator with the knowledge to make a critical process decisions. And variable organic loads in production effluent, limited equalization tank volume, unbalanced CNP. So if decisions are not made in timely manner, would lead to inability to manage varying wastewater influent, validate carbon levels. So ZLD concepts are emerging. Reusing the water, TOC valuable to determine membrane integrity, RO filing. So treatment water quality user can make a quick decision. So it is also the power of TOC is for regulatory monitoring as well as asset protection and process control allow to move towards the future exemplary monitoring. So it guarantees the longevity of membranes function at primary efficiency. It has advantages for plants to track organic content level of water directly upstream of the membranes. The capacity is the carbon loading directly at high speed is propelling organic analysis past regulatory discharge compliance into cost reduction via process control and asset protection. So my message today here is AOC is a very good tool for you as a water quality index. Periodically you check your water resources quality, then see at different stages of water treatment whether TOC is getting down or not. Even boiler water, there was a limits given for TOC. Please check whether the TOC are within the limits or not. Cooling tower also, if you know the inlet makeup water TOC, then you decide how many cycles it can go through and when to discard this cooling tower water lead out. So all these things can be taken a decision. As again in wastewater optimization, process monitoring, asset protection, TOC has a great role in that. You can see upstream, downstream, or in a typical power plants when I explained these different areas, oil water is go to the ETP, then ZLD, unit by startup water drain will go to ZLD discharge system into ETP, then boiler ancillary equipment wash water, flue gas treatment wash water will go to ETP. Boiler chemical drain, again boiler chemical cleaning neutralization pit, then go to ETP. DM water equipment regeneration, condensate polish regeneration drain, go to DM water neutralization sludge pit, then hash handling system, water use system. So core handling system, cleaning draining to coal yard wash drain. So all these areas TOC you can use and you can optimize your treatment plant. ZLD is a concept emerging. And I understand most of the power plants, 50 kilometers radius, if you have any STP people, you have to use that water, treated effluents, sewage. And by using that, there is a tariff benefits are being given in thermal power plants. This type of things are being given by government. So TOC measurement, the terminology is total organic carbon, TC total carbon, IC inorganic carbon, POC purgeable organic, NPOC non-purgeable organic, DOC dissolved organic, SPO suspended particulate organic. Two methods are there, difference and additional method. Difference is one step is TC measurement, and there is IC measurement, TC minus C. Everything is automatic. We are not doing anything. I'm just explaining how it is analyzed. So everything automatic, 8-port valve is there. So sample is sucked by syringe and pushed into 680 catalytic conversion, convert everything into CO2, detect with NDIR. That is TC measurement. IC, the sample is injected to IC reaction vessel where the phosphoric acid converts IC into CO2 and liberated. So TC minus IC is how you measure. And another method is NPOC, POC. Basically, here is one step only. You remove IC and measure balance sample as a TOC. But while you are removing IC, you are purging the sample. So if any purgeable organics there in the sample, it go out. That's why POC and POC have been defined. Balance sample as NPOC. So here we don't use this reaction vessel. We use the syringe itself as a reaction vessel. So sample is collected, then acid is collected automatically, and IC converted CO2 is purged out. Then balance sample we inject into catalytic conversion port where it converts CO2 and measured as NPOC. In case if sample contain POC, normally POCs are not there. So in case if it is there, then you have a purge trap, one trap system where when you are sparging out CO2 of IC, you remove the IC CO2 and balance POC is injected here. That is how we measure TOC. And measuring technologies, I skip I don't know the time I have. So the best technology is combustion, catalytic combustion. That is the key to select. And 680 is the innovative technique. And there are technology-based two products we have: online TOC, lab TOC. Both options we can give you, and highest performance product. And we are dealing this product 27 years in India with a Simasdo Japanese brand, and supplied thousands of this instrument for various application. For past 2-3 years, we started supplying to power plants. NTPC, we supplied many plants, and we have a high sensitivity 4 ppb, and highest range up to 30,000 ppm we can measure. We have a TN option, solid sample option, gaseous sample option, strong acid or alkali or strong salt samples, even seawater we can, brackish water also we can analyze directly. We have auto sampler options, whether we have this type of auto sampler or very simple 8-port auto sampler where you can use your own bottle. I can have a 16 maximum. Or solid sample module, 2 furnaces we have for TCIC measurement. It's a very unique product we have separate. Total nitrogen option is there, 5 pp, 10,000 pp with the same TOC add-on module. I can measure total nitrogen also. Huge installation base in India, more than 900 number of MCs are already operation. We also have water purification system like Miliku water, which is required for your laboratory instruments. Anybody is interested, we can give a separate presentation for that. So this is my presentation today: how to optimize your plant, plant water usage by monitoring TOC at various places. It's a wonderful tool, and by investment on TOC, you can save a lot of your energy, and water use optimization also can be possible. Thank you very much for your time.
Thank you, Mr. Kumar, for your presentation. I hope you can hear me. Mr. Kumar, we have one person who wants to ask a question to you. We have Mr. Satyanarayan Rao, who would like to ask a question. Mr. Rao, would request you to turn your video on. You can go ahead and ask your question to Mr. Vijay Kumar.
Thank you. Yes, please.
Mr. Rao, please go ahead and ask your question. You can turn your video on as well.
Good evening, madam. Can you hear my voice, madam?
Yes, we can hear. Please go ahead.
Yeah. It's a very nice presentation. Now I have seen this regarding TOC, madam. The small issue, doubts we are having. That's what we want to ask Mr. Vijay Kumar, sir. Regarding, sir, what will be the cost of that equipment, sir? First of all,
that is the final question, sir. I already selling to NTPC with the auto sampler, just the basic TOC analyzer. It is around 15 lakhs you have to budget.
15 lakhs. Okay. Why? Because we want to go ahead with that. Actually, it's a very good equipment. With that water monitoring in power plant is very important. Water is very important. This thing, no, sir. Input.
Definitely, sir. We'll come back to you. We'll discuss with you.
And also one more thing, sir. Actually, after identifying with the TOC, only we can measure the TOC. I think so. How to treat that again means there must be some solution regarding that. No,
Yes.
whether you will be suggesting some solutions for that. Or?
I can suggest you. Already it is there. Organic scavengers are available. Big power plants, already people use this polisher. Those are all called organic scavengers. Yes. Charcoal towers, organic scavengers are very much available.
What will be the cost about that? Means we have to see that means whether it is cost viable or taking this TOC, and without that it will not mean, I think so, sir. Because
no,
why?
But
because
we can always give a suggestion. There are a lot of people who supply that, but we are not directly in that. But
okay.
Yes, I can link to you some people who are expert in it.
Okay, sir. If that is a help, if you can do that help, now, sir, we can go ahead with that also. And if needed, we will visit your plant. It is means our plant is located at Mancherial district.
Yeah, I know, sir. I know SSCL.
Yes, sir. Exactly, sir.
Okay.
Then we can visit your plant also to get some idea if you give any opportunity. Thank
Yes,
you.
sir.
Thank you, Vijay Kumar, sir.
Thank you.
You have given a beautiful presentation.
Thank
Thank
you,
you,
sir.
madam. Thank you. Thank you very much, madam Anushi, madam, for giving me this opportunity.
Thank you. Thank you, Mr. Rao, for asking your questions, and thank you for Mr. Vijay Kumar for a very insightful presentation. A lot of ground was covered, and I think it has been quite fruitful for everybody who has been attending this session. Thank you so much for giving us your presentation, Mr. Kumar.
Thank you. Thank you, madam.
Right. So now we will try to go back to one of the sessions that we couldn't get started because of technical issues. And I will try to invite Dr. Bandhu to come onto stage and give us his presentation. Just give me a minute. Katiji, Mr. Bandhu, I don't see him. I don't know if, I'm not sure if he's around. If you could invite him, because I'm trying to invite him onto stage so that he can give us his presentation. I think we'll just take a break, a short break, and we'll try to find our speakers and we'll come back again. Welcome back. We have sorted out some of the technical issues we were facing, and we are going to move ahead with our session on establishing water balance and flow management. Given the accumulating water-related pressures on power plants, they need to have a clear understanding of how they will manage water and wastewater internally. Developing a plant-wide water management plan is the first step. A comprehensive site-wide strategy for maximizing water use efficiency, minimizing wastewater discharge, and reuse or recycling to the maximum extent possible is the need of the hour. Now, we will now explore the establishing water balance and flow management. Please welcome Dr. Dholak Prasad Kushava, Senior Manager Environment, MD Power. He's now joining us to give us his presentation. Good evening, Dr. Kushava. Thank you so much for being with us. Sir, I request you to please start your presentation and address the audience.
Okay. Good morning to all of you. First of all, I would like to say sorry because I have wasted lots of time of all of you because of technical problem, and it was not in my control. Now I want to start my presentation. Uh, am I audible?
Yes, sir. We can hear you and we can see your screen also. I would request you to please go full screen and start your presentation.
Okay, okay. So, I am starting my presentation. First of all, I would like to introduce myself. I am Dr. Bhola Prasad Kushwaha, Senior Manager Environment from MB Power Madhya Pradesh Limited, Anuppur. Uh, our our plant is located in district Anuppur and state of Madhya Pradesh. It is surrounded with district Umaria, Sadol, Korea, and located in Madhya Pradesh. It is 1200 megawatt coal-based thermal power plant, and we have 2 number units of 2 into 600 megawatt coal-based subcritical thermal power plant. Coal is primary fuel for our plant, and it is being supplied by SCCL. Water source for our plant is Son River. Power is evacuated through double circuit transmission line network through PGCIL. Power of our plant is mainly supplied to UP, MP, and Haryana. Some efforts are given here with respect to water conservation, like water is being drawn from the Son River with agreement signed between company and Water Resource Department, Government of Madhya Pradesh. Water intake data is being submitted to Water Resource Department, Government of Madhya Pradesh on monthly basis, and a representative of Madhya Pradesh Pollution Control Board visiting our reservoir to check the quantity of water. Earlier we have signed an agreement to take water for 34.5 MCM per year, but we have optimized the usage of water and revised the agreement from 34.5 MCM to 26.4 MCM per year. We have taken additional efforts further to optimize the water from 26.4 MCM to 10.6 MCM in 2019 and 7.26 MCM in year 2020. But we have saved the total cost of water in year 2019, 2.5 crore and 2.96 crore in 2020. Estimated quantity of water is given in the table. So we have given here monthly water consumption.
Mr.
First,
Prasad,
in the second column, this is the permissible quantity of water as per agreement. Actual, and next column in 19 and 20, it is the actual water consumption quantity month-wise. The rate of water is 1.55 rupees per meter cube.
Dr. Kushava, I'm so sorry to disturb you.
As per MOEF notification 7th December 2015, norms for our plant.
Dr. Kushava,
3.5 meter cube per megawatt hours, because our plant is started operation in the year. We have achieved 7 to 8 COC with implementation of advanced cooling water treatment system. In our plant, we have 100% recycling of water is done. 100%.
Dr. Kushava, we have lost your presentation. Can you please restart your presentation?
Treated wastewater being used in horticulture, dust suppression. BMB Power Madhya Pradesh Limited consumed less than 2.5 meter cube per megawatt hours water in year 19 and 20. Specific water consumption in the year 2020 was 2.17 meter cube per megawatt hours. In the current year, it is below 2.17 meter cube per megawatt hours. Total saving of cost in 2020 was.
Dr. Kushava, we have lost your presentation. Could you please restart your presentation? Yes, Dr. Kushava, we've lost your presentation. Can you please switch on to the low HD, low definition mode and restart your presentation, please? Dr. Kushava, we've lost your presentation. मैं आपको सुन पा रही हूँ डॉक्टर कुशावा, पर आपकी ना प्रेजेंटेशन बंद हो गई है. आपकी प्रेजेंटेशन बंद हो गई सर, उसको वापस शुरू कर सकते हैं आप?
Hello.
Dr. Kushaba,
Am I audible, ma'am?
Yes, sir, we can hear you. Can you please restart your presentation?
आप सुन पा रहे हैं मैम?
जी हाँ.
Okay.
Presentation. Please start your presentation.
Okay, ma'am. So specific water consumption of our plant in meter cube per megawatt hours is given in the table from January 2020 to December, and against permissible limit of 3.5 meter cube per megawatt hours, we have consumed only 2.17 meter cube per megawatt water. This is the trend of water consumption in specific water consumption in meter cube per megawatt hours, which is in reducing order. In year 2016, we have used 2.23 meter cube per megawatt hours one, and in the recent year 2020 it was only 2.17 meter cube per megawatt hours. We have given here best water consumption practices. Hello. हेलो,
आपका प्रेजेंटेशन नहीं दिख रहा, आपका जो
नहीं,
प्रेजेंटेशन है ना वो हट गया है।
एक मिनट।
आप शेयर करिए
जी।
अभी जो ऑनगोइंग है ना उसको स्टॉप शेयरिंग कर दीजिए।
ओके।
एंड फिर आप वापस चालू करिए तब हो जाएगा।
स्टॉप शेयरिंग। स्टॉप शेयरिंग।
जैसे आपने पहले किया था ना, एग्जैक्ट सेम प्रोसेस फॉलो करना है हमें। और आप जी हाँ, जो भी अभी स्क्रीन चल रही है आप स्टॉप शेयरिंग का ऑप्शन होगा, कुछ मेरे पास आ नहीं रहे तो मैं ऐसे कर देता। फिर आप एक बार वापस वो अप एरो वाला बटन दबाइएगा तो स्क्रीन शेयरिंग का ऑप्शन आएगा।
स्क्रीन शेयरिंग का एरो वाले में स्क्रीन शेयरिंग का है, बट ये एक्टिव नहीं है।
आपने स्टॉप शेयरिंग किया हुआ है ना पहले?
हाँ, पहले किया है। नहीं, स्टॉप शेयरिंग नहीं दिखा, इसमें दिख नहीं रहा स्टॉप शेयरिंग।
अच्छा ठीक है, तो आप एक बार फिर से वो प्रेजेंट ऑडियंस वाला बटन दबाइए। आपको वहाँ पे स्क्रीन शेयरिंग का बटन दिख रहा होगा, आप उस पर क्लिक करिए।
शेयर स्क्रीन आ रहा है, एरो।
हाँ जी, वो क्लिक करिए।
स्क्रीन शेयरिंग में इंटायर स्क्रीन विंडो।
हाँ, एंटायर स्क्रीन, नीचे आपको शेयर का बटन आएगा। जैसे ही आपने एंटायर स्क्रीन पे आप क्लिक करिए, नीचे आपको शेयर का बटन आएगा।
वो लेकिन वो एक्टिव नहीं है। एक तरफ लेफ्ट में शेयर ऑडियो है, राइट में शेयर एंड कैंसिल है, तो ये जो शेयर है वो इनेबल नहीं है सर।
अच्छा, तो आप एक काम करिए, आपको उसकी एंटायर स्क्रीन की साइड में विंडो या एप्लीकेशन ऐसा कुछ आ रहा है?
विंडो है,
विंडो पे क्लिक करिए, आपका प्रेजेंटेशन आपको वहाँ दिखेगा।
हाँ दिख रहा है। शेयर,
और उसके बाद नीचे शेयर का बटन दबाइए।
हाँ ये आ गया।
अभी
अभी स्टॉप शेयरिंग करना है।
नहीं रुक जाइए रुक जाइए। हाँ आपका प्रेजेंटेशन दिख रहा है, आप इसको फुल स्क्रीन में कर दीजिए।
ठीक, अब ठीक है,
हाँ इसको फुल स्क्रीन में कर दीजिए डॉक्टर बोला।
कर दिया कर दिया।
जी हाँ दिख तो नहीं रहा।
लेकिन इधर तो फुल स्क्रीन दिख रहा है।
अच्छा आप कंटिन्यू करिए, हो सकता है वो कुछ मिनट लेता है लोड में। आप कंटिन्यू करिए।
ठीक ठीक ठीक। There is some best practices for conserving water. In our company, we have made water conservation policy. Our management have committed to ensure the water by adopting water conservation policy, and it is signed by our top management. To conserve the water in our company, we are organizing awareness program for our workers and employees to conserve the water. We have displaying banners, stickers, and in several public places and water resource point to make the awareness to conserve the water. The person taking best efforts are being recognized by the management in the water conservation program, as well as World Environment Day program. Construction of stop dam. From our plant, a small perennial nala is being passed. In this nala, we have constructed 3 numbers stop dam to store the water, and this water conserve the water. This water is being helped to upgrade the water table of the region. We have a practice of water audit. In every year, we are conducting water audit through expert agency and setting out goal for next year water usage. Side in our cooling tower, side stream filtration of cooling water is being practiced. This increased COC from 8 to 9, and this reduced cooling tower blow down. Water treatment facility. We have effluent treatment plant of 1800 KLD in our plant premises to treat the industrial wastewater generated from different activities of our plant. All the waste water pipelines are connected with effluent treatment plant of our plant. We have sewage treatment plant in our plant and township area separately. Treated domestic water is being used in horticulture. Zero liquid discharge. Wastewater is treated in ATP and STP and utilized for dust suppression and green well and landscaping purpose. No wastewater is being discharged outside the plant. Zero liquid discharge is being maintained by us. For that, we have installed flow meter and camera, which is connected to state and central pollution control board. Conserving water is one of the vital water is one of the natural water resource. We have saved cost by saving water. Total saving of cost is 2.96 crore in year 2020. 100% dry fly ash handling system is there. We are collecting the fly ash in ash silo and we supply it to cement industries, and we are not storing any fly ash in our ash pond. So naturally we are saving the water which was supposed to use in ash slurry system. There is some photographs of STP, ETP, as I explained earlier. This is the effluent treatment plant of our plant, in which we are treating our trade effluent, and trade effluent is treated trade effluent is being used in our plant premises for landscaping and gardening, dust suppression, etc. This is the photographs of sewage treatment plant. In our township, we have installed 120 KLD capacity sewage treatment plant. This is the photographs of that. This is the photographs of cooling tower. This is the ash water recovery system, which is in our plant. We are showing here to use wastewater for the suppression in road. And this activity is being practiced in nearest villages also. From there, more vehicle movement is the nearest villages roads. We are using same water to dust suppress the dust from the road. We are using treated trade effluent in landscaping and plantation. As shown in the picture, we have laid pipeline in our plant all around the periphery and entire complete landscaping area. So in these area we are using only treated wastewater. These are the slogans for public awareness to conserve water. This is the drinking water point, and besides that we have fixed slogan to conserve water. Some activities related to water conservation we are organizing in nearest villages through CSR. Actually, this was the beyond plant, but I want few pictures. This is the pond deepening and watershed program conducted by the company. This is the pond deepening done by the company. Sir. Okay. आप कैसे रुक रहे Now it is okay. Hello. Hello.
Dr. Kushaba, we are unable to see your presentation.
At now?
No, your screen sharing is not happening, sir. We only see your screen.
Okay, I am trying again.
And perhaps you can also try going on the low definition mode. I think there's some connectivity issues because of which your presentation is snapping. On the lower right hand side, you will see an HD tab. If you press on that, you will see a low definition option also. You can switch to the low bandwidth mode as well.
Low definition.
Now you can select low definition and then go ahead with your screen sharing.
Okay, ma'am.
नेट उसी से चल रहा है।
हाँ सर। हाँ। वैसे किया वैसे कर रहा हूँ, लेकिन वो थोड़ा स्लो स्लो दिख रहा है, तो चल रहा है। किया हूँ वैसे, डाल दिया। हाँ 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 हाँ, वैसे वैसे किया। हाँ हाँ, मिल रहा है।
सर एक बार डिस्कनेक्ट करके कीजिए सिस्टम से।
कहाँ से देखते हैं?
इसमें
इसमें
हाँ एरो में जाइए। बंद करके कैसे कनेक्ट करेंगे?
हेलो। नहीं हो रहा होगा, बिल्कुल ऐसे स्लो है, ऐसा लग रहा है। हम्म हम्म हम्म, ठीक ठीक ठीक। हाँ, अभी ठीक है।
Yes, Dr. Kushaba, we can see your screen. Please go ahead to full
Okay.
screen and resume your presentation.
ठीक ठीक। ओके मैम। we have we have placed some display boards for public awareness about water conservation within the plant premises as well as nearest town. These are some photographs about water conservation we have placed in nearest town. Such type of slogan जैसे you are able to see here we have placed water source point for drinking water. Nearest that we have placed a slogan. Similarly, we have done some water conservation activities in nearest villages through our CSR team. You can see here some photographs, the pond deepening works. Next year, you can see in this water in that place. This is the pond deepening work done by us in nearest village. Thank you. Hello. Hello. Hello, ma'am.
Dr. Kushava, we can hear you. We can see your slides also. You can change the slides and proceed.
I can.
You can go to the next slide, sir. Keep your presentation running, sir. We can
This
see
is
it. We can
end,
hear
ma'am.
you.
This is
That's all.
that's all, ma'am. This is end.
All right. Thank you so much, Dr. Kushava, for your presentation. We've had a little teething troubles, but the audience has been able to see the efforts made by you in your plant in Madhya Pradesh. We have, I think, one question that has come in, and it is from Mr. Himanshu Gupta. I'm trying to take Mr. Gupta onto the stage so that he can then ask his question directly to you. I think, Mr. Gupta, if you can hear me, please go ahead and ask your question. I think I don't see Mr. Gupta on the stage yet. Okay. I think there's some difficulty in getting Mr. Gupta on stage, but what he wanted to see was your presentation, and he had sent us a message when your presentation stopped. Thank you so much, Dr. Kushava, for joining us today and sharing your presentation. I'm seeing the last slide. It says "Pani bachao." पानी बचाने का जो आपने स्लोगन डाला हुआ है, it is, I think, short, ringing a bell with the local as well as the employees in your plant. Thank you so much for joining us and giving us your presentation.
Thank you, madam. Thank you, madam, and sorry for disturbance between
No
presentation.
problem. Thank you.
Okay, madam.
With that, we will come to the close of the Water Optimization Conference Day 1. We hope that you've enjoyed the sessions and picked up valuable insights for your company's operations to optimize the clean energy usage and reduce waste generation. Please join us again tomorrow at 10 a.m. sharp for more knowledge sharing through panel discussion and presentation sessions. We'll take your leave, but we look forward to seeing all of you tomorrow at 10 a.m. Do join us again.